Hi, everybody. So let's kind of dust off those rusty brain cells, which happens over spring break, and let's just do some of these together here. Okay, I'm going to do these four on page 18 with you, and then these two on page 19. And I think after that you can let me know, but I think you'll feel pretty darn good about things. All right. So number 2 and 4, I'm going to write them down. Number 2 looks like this. 2a squared minus 36a plus 160. Number 4 looks like this. Number 4 is b cubed minus 18b squared, plus 80b. Okay. First thing I'm noticing, everyone here, the directions. The directions are asking you to factor. Okay. These are expressions. They are not equations. So it doesn't say solve, right? So that's the first thing we want to make sure we pay attention to. And I'm remembering when we factor, like big time factoring, right? Factoring, we always look for what first, and then what do we check? What do we always look for first? Yes, we look for a GCF. Sometimes you'll have one, sometimes you won't, but we always look for one because that makes things easier when we are tasked with fully factoring. So number 2 here is a GCF of 2. I'm going to factor that out, and I'm left with a squared minus 18a plus 80. Okay, and then look over here. So I factor the GCF out. This is now a quadratic. Quadratic means just degree 2, right? Degree 2. A quadratic, it's a trinomial. Okay, I don't think we've done that vocabulary yet, but there's 3 terms here. We're going to try to unfoil. Oh my goodness, let's dust those brain cells off. We're going to try to unfoil. We're actually happy because what's the coefficient of the degree 2 term? Yeah, the coefficient here is 1. We love when it's 1. Okay, so we're going to put A and A here. Okay, and what do you think? What do you think? Haley, factoring goddess. Minus 10, minus 8. Remember, when we're unfoiling, so to speak, we want these two numbers down here. These two numbers, notice how I take the sign with me. These two numbers have to multiply to that, right? And then we know that if we are checking the negative 18, we want the negative 10 times A and the negative 8 times A to equal the middle. Okay? All right. Some of you may be motoring on ahead. Go ahead, do number 4, and then check me for the answers. Okay, everybody. Hello. So once again, there's a GCF of B out here. And look at that. I'm wondering, why do they make these in the back, these questions so easy? Like, why would that be the same thing? How silly willy. Okay. But the point is, now we have a complete factorization. Okay. Number 12 and 32 are both solve questions. Solve for X. What kind of equations are these? Oh man. They are quadratic. Okay, they're quadratic, degree 2, right? But number 12, it's specifically telling you to solve by factoring. I'm going to add to this. Let's say you were told to solve this in the most convenient way possible, okay? Because we're going to do it both ways. I'm noticing there's no x term, right? If there's no x term, I might as well just try and get the x squared by itself and then use the square root method. Add 14 to both sidesies, and I get x squared equals 9. Square root, x equals, plus or minus root 9, plus or minus root 9, or plus or minus 3. Now, let's just deal with the directions. It says solve this one by factoring. Let's redo that. Solve by factoring. Remind me, if I'm solving a quadratic by factoring, what's the first thing I need to do? Sing it loud and proud. Yes, you have to set it equal to 0, right? The 0 product property. X squared minus 9 equals 0. Okay, so if I'm solving by factoring, I want to set it equal to 0, check, and then I try to factor. Oh gosh, there's no x term, and I think I remember telling you that sometimes if you are thrown for a loop here, maybe you'll do that. I think it was Ava who said, or Delaney, I can't remember, it was that part of the room, like middle-ish, that this is actually a factoring pattern that has a name for it. It's the difference of squares, right? Okay, and we see that, oh, x minus 3 could equal 0, x plus 3 could equal 0, and doink, 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 at the end of the day, doink, 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 x equals -3 or +3. All right, awesome. 32, oh my, our favorite blast from the past. How do they want us to solve this? Solve this by the quadratic formula? Oh, heck no. Let's just review completing the square. Yeah. We're going to do 32 by comp the square because that part requires review. Solving by the quadratic formula, good grief, you can just look the formula up and just bang it in. So I'm going to solve 32 by comp the square, but when you go back and do 32, you're going to solve it according to the directions. Solve by completing the square. What's the first thing I have to do? So when I look at this equation here, and it is quadratic, right? Just double checking. Here's where it's 6 of 1/2 dozen of the others. Some of you may say, for completing the square, a has to equal 1. Yes, 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 yes. And maybe when you look at this, you're going to divide everything by 2, but you'll get fractions here and here. And maybe you're saying, I really don't like fractions because that's just too early in the morning. And so maybe you may want to do this. Or maybe you're saying you're like really into fractions right now. You know, you've kind of gotten over your phobia of them and you're ready to enter a long-term relationship with fractions. You don't have kind of commitment phobia with fractions, but you're able to get over that. And maybe you divide by 2 and you have the fractions and then you combine them. Either way, I digress. But yes, a does have to equal 1. However you get there, we get here. What's the next step with comp the square, everyone? What is it? Move the constant. R squared minus 6r. Leave a little gappy wappy equals 10. Oh, we add something to both sides. What do we do again? Yeah, we take half of this number and then we square it. Half of -6 is -3. -3 squared, what is it? Yes, it's +9, and we add that where? To both sides, indeed. And then we ask ourselves, is this factorable? And it is. And remember, when we complete the square, we will always have or create a particular quadratic that factors in precisely this pattern. Gold star for someone who remembers that pattern or that kind of a pattern here. This is called a perfect square trinomial. Something that factors as something times itself is a perfect square trinomial. Now what do? What do we do? Yes, we square root both sides. And we get r minus 3 equals plus or minus root 19. And then we solve for r. R equals 3 plus or minus root 19. Root 19 is prime as can be, so we can't do anything with that. Okay? How'd that feely wheelie? Nice, 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 nice. Okay. Where are we now? Page 19. Your little mental wheels should be greasing up. All right, 19. Here's a challenge. Numbers 6 and number 11. Identify the vertex, the axis of sim, direction of opening, and the y-int of each. Remember that day we pulled out our binder and we filled out that whole page of notes on quadratics that was inspired by Ava, because Ava came to the office to do that with me. It's on page, Roman numerals. It's page XVIII. That's page 18 in Roman numerals in the very front. Here's a challenge for you. See if you can figure out all the body parts here by looking at your notes. Basically, this is a test of how good are your notes, how clear are they? And then replay me for the answers. Ding, ding, ding. Are you ready? So, let's see. What color should I pick, everyone? Pink. I know. All right, let's see. Here's the parabola, and if you look at your notes, this quadratic is in standard form. Parabola opens down because the a value is negative. The y-intercept is 0, -6. The y-intercept of any curve is the resulting y value when you plug in x equals 0. We will never write something like the y-intercept is -6. We will always write the ordered pair, my dear students. And I remember this moment in class when Dominic discovered the -b/2a as the x-coordinate of the vertex, -b/2a. So negative the +2 over 2 times -1/4. Fraction commitment worries. But if you stay cool and composed, you get there. That's the x-coordinate of the vertex is 4. How do you find the y-coordinate? Yes, you plug that x value in for x in the equation, and you are very careful as you plug and chug it all the way down. So the vertex is 4, -2. The axis of symmetry is always the x value. It's the vertical line that passes through the x value of the vertex. So x equals 4. How did that feel? Great. Okay, number 11. Let's do that together. I shall pick a nice citron yellow. You know what? Let's do it again. Try it on your own. Try it. Try it. You'll never know if you don't try it. And then play me for the answers. Hi, everyone. So the first thing I did, look how I have some graph paper here. Isn't that awesome? It's really kind of fun. On your graph paper, and yes, look at my x and y axes. I just drew them like that because my points are all the way down here in quadrant 4. But let's see. You were told that this point is the vertex, and it passes through 1, -11. So if I were going to be really smooth about this, right? It should be a roundy, roundy, roundy. Okay. So, 2 negative. So I know for sure it has to open down, right? That's the vertex, and it passes through this point. And something tells me, I remember vertex form of a parabola. And I remember vertex form looking something like this. We may have used different letters. I don't remember. Texts differ. But the point is, y and x are our variables. And we have the h and the k and this a value. And I remember us saying that a was like the slope. But we always put the slope in air quotes because these are not lines, right? Okay. Oh, what did the h and k stand for? Yes, the h and k were the coordinates of the vertex. And remember, it was always, right? I think we use the word like h. It's like the fact that you have a -2 here, the x, the h rather, the -2 is always the opposite of the x coordinate, but the y coordinate was the same. I think we used that language. What about the a? The a. Well, let's see. Let's remember for a second. The a was determined by figuring out if you were to move 1 unit to the right and 1 unit to the left of the vertex, on the parent parabola, the point that falls on the parabola is typically just 1 unit above or below. That's the parent, right? But in this case, if I go 1 to the left or 1 to the right, I don't go 2 units away. Sorry, I don't go 1 unit away. I go 2 units away. I go 2 units away and I go 2 units down. So that makes this A value -2. Oh my gosh, what did I forget in this beautiful citron green? I forgot the doink. Silly yam. Squared -9. All right, folks. So with that, I think that was a pretty nice review / dusting off our brain cells. I mean, it's the same thing we did after winter break. Do you remember that when you all came in like crusty, dusty, shiny, clean, but forgot everything? It comes back quickly. All right, everybody. Great job. I will see you. I think I see you tomorrow. Yeah, I see you Thursday. All right, bye.